All right, CC7 world out there. We are looking at problem number 1, A and B, the graph on the review here. And the question asks, what is the rate for the graph? Now remember, rate is whenever time goes up by 1, what is distance doing, or what is miles doing? So it's helpful to put in the ones, and in between 0 and 2 is 1, and then we got 3, and we got 5 here, and I think we can see that pretty well. Might be good to put in our missing data over here on the left-hand side as well in our y-axis, and between 0 and 10 is 5, and 15, and 25, etc. So when we're looking at the rate, we need to ask ourselves, what is the, when x is going up by 1, what is y doing? Well, instead of starting at 0, 0, or the origin, this one on the y-axis starts at 5. So we have to start here at the end of our line, and we go over 1. Okay, x went up by 1. What is y doing? Well, it's going up from 5 to 15, or it's going up by 10. Let's test that again. When x goes up by 1, what is y doing? It's going up by 10, from 15 to 25. So the rate is 10 miles over here per every hour. So 10 miles per hour. All right. Then it says to write an equation for the relationship between hours and miles. Okay, remember that the equation always starts with the y-axis data. So we need to know miles equals something times something, and we might even have a plus something at the end. Let's check. So miles equals, well, the only variable left is hours times what? Every time an hour goes up 1, miles goes up by 10. So our rate is 10, and we take that rate and we multiply it by the number of hours. But now we're almost done here. We've got to pay attention to where we start on the y-axis, though. And remember, used to be when we just had going through 0, 0, that would be the end of our equation. But since we are not on 0 on the y-axis, we need to pay attention to that, and we start at 5 here. So our y-intercept over here is plus 5, and there's our equation. The miles, we can figure out the number of miles by taking 10 times the number of hours we've traveled, and then add 5 to that, and we will get our total. And we're looking at a table here with number of days and hours worked. And notice that the number of days goes up by 1, 2, 3, 4, and the hours worked goes up, well, let's see what it goes up by. Well, it looks like it goes up by 6, right? It's 6. So it is 6 hours per day. All right, there's our rate. Yeah, let's see, when the x value goes up by 1, what does the y value do? And that's your unit rate right there. Write an equation for the relationship between the number of days and the number of hours, right? Because we have that formula, y equals mx plus b, right? So here's our y, here's our x, okay? Hours worked, h equals something times x plus b. So hours equals, what are we going to, what's our rate? Well, we know our rate is 6 times the x, which is the number of days. So 6 times that, I'll make that a 6 a little bit better. 6 times the number of days. Now we got to say, does it start anywhere other than 0, 0? So now we should go backwards here and go back 1, and we're going to end up at 0, and go back 1, our rate here, 6, and we should end up at 0. So the answer is no, it doesn't end up anywhere except for 0, 0. So we could either put plus 0, or we could just say, or h equals 6 times d, and leave it at that. All right, that's a good answer. Now get down to here, what is the rate for Mr. Greg? Okay, as he's getting paid over here for mowing lawns, good for him. And this one is actually quite easy. The rate is in it. Mr. Greg gets paid $30 per hour. You don't have to go any further than this right here to find his rate. Okay, $30 per hour. Rate always has a per or for every statement. Then it says, what is the equation that represents the money in Mr. Greg's bank account at any given time? We have hours and we have money or dollars, right? So I think we're going to have to use our hours over here per hour to find our money. So let's use M for money. I'm going to put it right in here. I don't have any room below that other one. M or money equals 30 times the number of hours. But let's go back. Does he have any money before we start working any hours? And the answer is yes, he already has $100 in his bank account. All right, so before we go to $30 per hour, we need to add that $100 because even when he doesn't work an hour, he still has $100. So there's our equation. M equals 30H plus $100. And here we go for problem number 2. A and B, we're going to do some solving of equations. First thing we're going to do is put our line down on our equation. Nice, Mr. Sorello. And we're going to ask ourselves, how are we going to undo the 9x plus 19? How are we going to undo? What do we undo first? Well, we're going to get rid of the 19, and we need to do the opposite operation. And this is a plus 19, so we're going to subtract 19. And whatever we do for one side, we do to the other, right? Keeping that equation balanced. All right. And we're left here with just the 9x. We're going to move it over. So 9 times some amount, and 46 minus 19. Do a little math in my head here. 16 minus 9 is 7. It's like 27, right? So 9 times some number equals 27. Undo the 9. It's a multiplying by the 9 times x. We're going to divide by 9. And then we're going to divide by 9 on this side as well. And we're left with x equals 3. Now we're going to check that work. We're going to take our equation, go back and write the equation, and we're going to say 9 times some number, whatever we think that is, and it turns out to be 3, plus 19 equals 46. And let's see if it's true. Let's get our 3 in there first. So 9 times 3 is 27. 27 plus 19 is indeed 46. And we have double checked it. You can also use your calculator to make sure that's true. All right, so let's get to this one over here. This one includes a factored form. You see the parentheses. Anytime you see parentheses, you know you're going to need to expand that. All right, so expanding means you take the 2 and you expand it to the 4x, or the negative 4x actually. We'll talk about that in a second. And then you also expand it to the 5. Now, I draw those arrows to start with just to remind myself I need to do both. So 2 times negative 4x, the whole term there actually means, or actually is negative 8x. 2 times 4 is 8. You keep the negative and the x. Keep our subtraction sign there. And then we multiply the 2 times the 5, and that's 10. So we get negative 8x minus 10 equals negative 28. All right. Let's put our line in. Let's undo. What's my first undo? I think I'm going to go a different color here just to let you see it better. The undo, since that's a minus 10, or some people like to say plus a negative 10, right? Plus a negative. Make sure you understand that that's a negative there. So plus a negative, how do I do a negative? I need to add 10, or if you just see the minus 10 there, you can add 10 over on the other side, and I get negative 8x equals negative 18. Be careful on this. You're starting at negative 28 and you're going up 10. All right. Divide both sides by the negative 8 because we want negative times the negative gives me a positive x, negative 8. I'm running out of room for my check. We'll do that in a minute. X equals a negative times a negative is a positive, and 18 divided by 8 is x equals 2.25. And there we go. We'll check it in a minute. All right, here we are. I have already written in our problem here for checking our work for problem B. And we have the 2 times, and notice I wrote that in brackets. That's so when I write parentheses, I'm not confused by all my parentheses. I don't have to do that way, but I do it. Now what we're going to do is we're going to substitute in our answer 2.5 right in here for x, and we're multiplying negative 4 times 2.5. Okay, minus 5 equals 28. That's what we said the whole problem is. So we do negative 4 times 2.5, which turns out to be negative 9. Negative 9 minus 5, we still have that. I'm not getting any. Okay, minus 5 equals negative 28. I forgot to write the negative up here. So plus negative 5, and that's a negative, oh, we forgot to put our 2 times all of that out there. So negative 9 plus negative 5 is negative 14. 2 times negative 14 equals negative 28, and we have checked it. All right, here we are with problems C and D, number 2, page 2. And as you see the first one, I'm just going to draw in our line there. You see the first one. Let's undo the 8. Undo the 8 by subtracting 8. What I do to one side, I need to do the other. Then I end up with negative 1/4 times some number, or negative 1/4 x equals 5. Okay? So the question is, when we have a fraction next to a variable, how do we get rid of it? Well, the nice thing is getting rid of a fraction is dividing by a fraction, and without going too detailed, dividing by a fraction is flipping it and multiplying. So let's do that. And we have a negative 1/4, so let's keep the negative, because a negative times a negative equals a positive, and that's what we need, a positive x. But we're going to flip it. Negative 1/4 flipped, or the reciprocal, is 4/1. Whatever we do to one side, we need to do the other. We're going to multiply that by negative 4. We don't have to put it over 1 on that side, so it's kind of nice. These cancel each other out, right? This multiplies by this, and it becomes a 4, and that's a 4. So they all actually cancel each other out, and a negative times a negative is a positive. So I'm left with positive x equals 5 times negative 4, and a positive times a negative is a negative, and it's negative 20. All right, let's check that. This will happen to you sometimes too. Negative 1/4 times, we think it's negative 20. I'm going to put that over 1. Plus 8 should equal 13. So a negative times a negative is a positive. Man, I'm hitting buttons all over the place. And so we get 20 over 4. And we already know 20 divided by 4 is 5. Plus 8 equals 13. Let's finish it off. 5, plus 8, you can see me, you can hear me, equals 13. And that's our check. There you go. Let's look over here and see what we have with this one. Now we need to expand this again. We see another expanded. Notice we have an x here and an x here, and some of you want to combine those already. We've got to expand first. So let's expand before we combine. You have to expand first and then combine them. So that's a 4x plus, make sure to multiply the 4 times the 3. That's 12 minus 2x should equal 4. Now we can combine those terms. Let's do it. This one and this one. Wrong way. Oop. My bad. Let's do it again. This and the x's, and 4x minus 2x, or plus a negative 2x here, is 2x. Okay. Get back to our other color. 2x. And then we have that plus 12 in there. Don't forget that. Equals 4. 2x plus 12 equals 4. Now we can draw our line. Now we can solve it. So, how do I undo the 12? Subtract 12. Subtract 12. I see we're approaching our time limit. We're going to have to get done with this. Negative 8. 2x equals negative 8. Divided by 2. Divided by 2. X equals negative 4. All right, here we are. Let's check this. I've substituted the negative 4 in for x, and both times we see it, so we're about to solve it. Make sure you do order of operations. Solve the parentheses first, and negative 4 plus 3 is negative 1. And we're going to have a 4 times the negative 1 over here, and we're going to take away from that. 2 times negative 4 is negative 8. Okay, equals 4. So we've got a 4 times negative 1 is negative 4. But subtracting a negative is the same as, you should be saying this out loud with me, adding a positive. I'm sorry, in the wrong place. Adding a positive, right? That would have up there done plus a negative. I didn't do it, but adding a positive. So negative 4 plus 8 is what we're going to have now, equals 4. And if you know your number line, negative 4, and we go 8 to the positive, we end up with a 4, and we are done. All right, here we are with problems E and F from that second page. And as you see on the first one, we need to expand the 2 and multiply it into the x and the 5. So 2x, and you see the minus sign, keep it there, but don't forget the 2 times 5. Don't leave a 5. This is minus 10, equals 40. And now we're able to draw our line. So how do I undo a minus 10? I add 10. I add 10 over here. I end up with 2x equals 50. Divide both sides by 2. And I get x equals 25. So now I'm going to go down here and check it. So 2 times 25 minus 5 should equal 40. And let's do what's in the parentheses first. We don't need to do any expanding or anything like that. 25 minus 5 is 20. 2 times 20 equals 40. And we got it. Okay? Now over here, we need to combine some like terms. See those there? And you see these there. Now, the big deal is to remember that this is a negative 15x here in front, and this is a minus 10x. I tell my class, and don't subtract a positive, add the negative. And that's really important to do, because now I know that I have a negative 15 and a negative 10x, negative 15x, negative 10x. Let's bring it down here. So what's negative 15 and negative 10? Negative 25x. Not a very good 2. Negative 25x plus 20 and 7. Pretty easy there. 27 should equal 77. Let's put our line in. Let's get rid of the 27. And I get negative 25x equals, and this is 50. All right, dividing by a negative 25 to get rid of that. So I get a x down at the bottom instead of a negative x, divide by negative 25, and I get x equals, and this is a positive divided by negative, that's going to be a negative, 50 divided by 25, there's two 25s and 50, there's my answer. X is negative 2. Now we got to go back and substitute it in. Negative 15 times negative 2 plus 20 plus, or minus 10, sorry, 10x, and x is negative 2 plus 7 plus all that should equal 77. So I'm going to start combining these. Negative 15 times negative 2 is 30 plus 20. And this is, I could either say minus 10 times negative 2, or I could do plus a negative 10. And negative 10 times negative 2 is 20. So plus another 20 plus 7 should equal 77. 30 and 20 is 50, and 20 is 70, plus 7 equals 77. I don't have room to combine all those, but we have done the work that it is equal. All right, problem number 3 says solve each inequality for x and graph the solution. Now remember, whenever you have an inequality, you basically solve it the same way we would solve an equation, except we have the inequality to deal with. And there's some few little things that we have to pay attention to, but otherwise we can do the undoing and get our solution and see what happens. So first thing we need to do is we need to undo the minus 1, and to undo a minus 1, we're going to say plus 1 here. And then we end up with a negative 6 times some number equals, I'm sorry, not equals, is less than 36. Less than 36. So we need to know x is going to tell us all the numbers that we can multiply by a negative 6 and still say less than 36. So the interesting thing is now, whenever we have to divide by a negative number, we need to flip our sign, okay? So get ready to flip the sign, because I can see we've got a negative number there, and we need to divide by the negative 6 so that we can get a positive x. So we're going to divide by negative 6. We need to divide by negative 6 here. So we are going to flip the sign now. Make that a little bit longer. Go back here, get another color. We're going to flip the sign the other way. Boom. Before I even find out what x is and all that. Flipping that sign. That's all I have to do. If I divide by a negative number, or multiply by a negative number for that case, I flip the sign. So negative divided by negative is a positive 1, or a positive 1x, I mean. X is greater than 36 divided by negative 6 is negative 6. So we think that our solution is any number that is greater than negative 6. And if you think back here, if we say any number that is greater than negative 6, let's try negative 5. Negative 5 times negative 6 is a positive 30, and we subtract 1, it gets us a positive 29, and that works. All right, so we just did that in our head just now. So let's go, we're going to do two things. We're going to graph this, and we're going to try that test point of the first number we think that is greater than negative 6, and here's a test point. I'm going to write it down for myself right now. I think that's negative 5, and because remember, you're going up on the number line. Let's graph this negative 6, though. X is greater than negative 6. You don't have to put very many numbers in. Negative 6, negative 5, negative 4. I might go a couple the other way. Negative 7, negative 8. And remember, the first thing is I find the number. Okay, is it open or closed? Greater is an open, right? If it's equal to, it's closed. Greater than or equal to means it's closed. And we need greater than, and so we're going to go greater than, and now we've graphed it. Let's test our negative 5 while we're still here. We think all these points work. The first one we see is negative 5, so let's test it. Let's get our original equation, -6 times -5, that's where our x is, minus 1 should be less than 35. -6 times -5, negative times a negative is a positive. 30 minus 1, you know that's 29, is indeed less than 35, and we have checked it. All right, 3B. Colby needs $218 to go to math camp this summer. That's a pretty big piece of information. He needs that, right? He has $125 already. I think that's a pretty big deal, okay? He earns $5 for each dog. Can you see the rate in there? $5 for each dog, or $5 per dog, we might say, that he walks. Now we have this question. What is the minimum number of dogs that Colby needs to walk to be able to attend math camp? Write your equation as an inequality and solve. I think it's helpful to write down what an equation is. Y equals mx plus b. I do that sometimes when I'm just working on this on a test or a problem to remind myself what I'm doing. So what would y be? It could either be the amount of money or the dogs, okay? But we already know that right here, it gives us a clue, $5 for each dog. I think the dogs are going to be X, right? Every time we walk a dog, we get $5. Ooh, there's our $5 per dog, right? And so what am I left with? Well, money, right? How much money I earn depends on the $5 per dog, but guess what? I already got money. Or Colby, I'm sorry, not me, has money, 125. So money equals 5 dogs plus $125 is our equation. But it says to write it as an inequality. So what does that mean? Well, we need money. We still need the $5 per dog plus the $125 he has already. But we need to know, it says the minimum number of dogs. So, right, he wants at least $218, right? So the way this works is we want this over here, how we figure out how much money we have. We want that to be more than the money, the 218. So we're going to actually substitute in the 218. Oops, sorry, $218. Okay, needs to be less than all that, or that needs to be more than the 218 plus $125. Now, I have shown my kids, and I think Mrs. Groh has done the same thing, that you can flip this around, and it actually solves a little bit easier, okay? 5D, 5 times the number of dogs, $5 times the number of dogs plus the 125, okay, needs to be greater than 218. Now we can solve it. We undo the 125. Don't be intimidated by big numbers. Okay? Then we get 5 times the number of dogs equals $93. Use your calculators. Don't be bashful. Divide by 5 to get rid of that. Divide by 5 to get rid of that. And it comes out to be that the number of dogs we need to walk is 18, I'm sorry, not equals. Oh man, I did the big no-no. Greater than, remember, it needs to be greater than, not equal to. Greater than, we need more money than 218. The number of dogs need to be greater than 18.6. Well, we can't round down, because if we rounded down, we would end up with 18, and that wouldn't get us enough money. And the rounding rules actually tell us to round up, but we need to pay attention to that. Are we going to get enough money thing? So really and truly, our number of dogs to walk is 19 that Colby needs. Okay, and that's going to get us the answer. All right, congratulations, you're on the last page. Let's do number 4. It says here to determine the equivalent expressions. Remember, that's just the equal expressions. And I think the best way to do this is I combine these already. I combine them up at the top and I look for the expressions that might be down there. Notice there's a variety of different types of expressions in here. So we're going to have to do some investigating once we get once we get our expression figured out to begin with, right? So let's figure this thing out to begin with. By the way, there's no multiplications in here, so all this is just combining like terms, even though we've got our parentheses. Don't be intimidated by parentheses. We've got a 5x and we've got a 12x. What do I have there? Oh, it's a negative 5. So 12 minus 5 equals 7x, okay? Or negative 5 plus 12 equals 7x. Plus, I always put my plus in here. Doesn't matter if it's subtraction or what, I can put a negative in there when I get ready. So let's combine the other terms. And we've got a 5 here, and we've got a 9. And 5 and 9 is 14. So 7x plus 14. Well, guess what? As I look down here before I can see anything else, I see 7x, 14 plus 7x, and I know that's true. I also am going to look through here and see my other, the one here. This is 5x minus 12x. Well, 5x minus 12x gets me a negative 7x. Guess what? That one does not work. I'm not going to put it on there. Let's get a different color. I don't like red. I mean, I don't like green. So let's get red here. That does not work. Then number 3, 12x plus 14 minus 5x. Well, I do have a 12x up here. Let's check this. Plus 14. Oh, you know what? I can see there was a plus 14 up here when I solved it. So this, oh, and the minus 5x was original. So I have a 12x, which was original up there. I have a 14, which is in my solution. And I have a minus 5x, which was originally there. Guess what? That one works. Well, here's another one that works. Now let's take a look at the next one. I've got a 5. Well, I had a 5 in the original. Then I had a minus 7x. Oh, here's what's wrong. This is a positive 7x in our solution. That does not work. Another one that does not work. Do a little investigating and you can find out what's going on. This one I need to expand. This has a 4 times 5x. Well, it gets me a 20x. And you know what? I already know that 20x does not work. I need a 7x. So guess what? I'm not even going to do anything. I'm just going to cross that out. All right, now we're ready to do 4B here, which is much the same process as we did with A. When I look at these and it says write 3 equivalent expressions, I'm first of all going to start simplifying this to see what it looks like as I simplify. And I can take simplified versions that are partially done and write these in here. I'll show you. The first thing I need to do is expand this 3, multiply it by x, and then 3 times 8. Truth be told, when I first did this video, I forgot to expand the 8, just like some of you are going to do. So it's actually 3x plus 24. Then I've got a 7 here. 7x plus 7x. I'm going to turn this into a negative 2 plus negative 2, okay? Or minus 2 plus negative 2. Now I'm going to combine these like terms. And then, first of all, there's one of my versions right there. 3x plus 24 plus 7x plus negative 2. That's a plus sign there. Plus negative 2. Okay. Now I can go on and start combining these like terms and get new versions. So if I combine the 3x and the 7x, what do I get? Well, I get 10x. And I still have the plus 24 and the minus 2. So let's do that one. So 10x plus 24 and the minus 2. Okay. If I want to go ahead and combine the 24 and the minus 2, what's 24 minus 2? That's 22. And I've got my third version, 10x plus 22, right? Pretty straight up. I could have also said 22 plus 3x plus 7x, or 3x plus 7x plus 22, and I would have had that as well. And congratulations, people. We are on the last two problems of the unit review. This one says, what is the value of a when the expression 88x plus a is equivalent to 22 times 4x plus 6? Well, here's a cool thing. If these are equivalent, then this equals this. And you may notice the 22 and the 4x, and some of you have already seen that 22 times 4 is 88x. That's a huge clue. So if we expand this 22 times 4x and then expand the 22 times 6, that should help us a little bit. So let's look at this. 88x from up here plus 4 is equivalent to that 22 times 4x, which turns out to be 88x, right? That's kind of cool. Plus, what's 22 times 6? Well, 22 times 6 is 132. So this, I'm sorry, this is an A over here, I'm sorry. This 88x plus A equals 88x plus 132. Well, A, as it turns out, you probably can already tell, equals, better color, equals that 132. So A equals 132, and that's as easy as it is to solve that problem. The next one is very much the same type of problem. It says 4x minus A is equivalent to 2 times 2x minus 6. And we're going to do the same thing. We're going to say 4x minus A is equivalent to, and let's expand this when we bring it down, 2 times 2x is 4x, and minus 2 times 6, right, is 12. So 4x minus 12. So this one is a little tricky if you're not careful. Remember, there's a minus sign in here and a minus sign in here. So if 4x minus something equals 4x minus something, well, that something is 12. So that A equals 12. And you're done. Congratulations for completing the unit review.